Let's begin. Static pressure in fluids. Now what is static pressure? It is the pressure due to the static fluid due to its certain height. Okay, now it is the pressure below a certain height of fluid. For example, you have this fluid here, its height is h. All right, now if you want to find the pressure at a, means this base. All right, then pressure at this level, that's the bottom, is rho g h. Okay, now how are we going to prove it? We have to prove pressure is rho g h. Now let me make a diagram here. I will explain how. Let's make a tank. All right, now this is like a tank. Okay, its cross-section area, this cross-section area is a. Okay, this cross-section area, so this will be a2, right? And its height is h. Okay, it's completely filled with water, like this. It's completely filled with water. Now we have to find the pressure at a. I mean, let this bottom be denoted by something like let me denote it by b. Okay, this bottom level. Now here will be another level too, like this, right? We will not care about that right now. Now pressure at b, p for pressure at b is, what is pressure? Pressure is force divided by cross-sectional area, right? If you want to find the pressure at this point, okay, now how, what pressure will be here? Like this is a bottom of the tank, maybe this is a steel tank. Okay, and of course there is pressure due to water it above it, right? So pressure at b is entirely due to the weight of this water above it. Okay, if we take the water away, the weight of water on this bottom base will reduce, the pressure will reduce. If we will add more water, the weight of water will be more, so the pressure at b will be more, right? So this force, pressure is force divided by area. At b is force is what? Force is due to what? Force is of course due to the this weight, right? Now according to the Newton's law, force is what? Force is, wait, let me write this as force is due to the weight, right? Weight divided by area, because weight is a force too, right? Now this weight, according to the Newton's law, it will be what? According to Newton's law, is force is mass times the acceleration, and in the real life on earth the acceleration is due to gravity g. Okay, so weight is mg, where m is the mass, and let this area as we had denoted area with A, so we write here A, right? Now we know density of any material is mass divided by volume, right? So we can write mass as density times volume, right? Similarly, here we can replace this m with density times volume, which will be density times volume divided by area. Of course, here is a G, right? Let me erase this. Now volume is what? What is the volume of this tank in terms of area, cross-sectional area A, and height h? It is of course A times h, right? So we can replace this volume here with A times h. So pressure at B is going to be density multiplied by A multiplied by h divided by A multiplied by G, right? Now this A and this A cancels out, so we are left with rho, let's write G here, and H. Therefore pressure at B is rho G H. Okay, that's why I write here rho G H. Now what is rho G? Rho multiplied by G is what? Rho G is unit weight, right? Rho G is unit weight and we denote it as gamma. That's why we sometimes write this as gamma multiplied by H, where gamma is unit weight. Okay, rho is the density of fluid. G, we know it is acceleration due to gravity, right? Which is value is approximately 9.81 meter per second square. So this way we found the pressure, the static pressure. Why we call it as static pressure? Because this water is stationary and we are finding the pressure due to the static fluid, right? Only due to its weight. Okay, and of course when the height will be more, the more will be the weight, so more will be the pressure. That's why here you are seeing pressure is directly proportional to the height, right? Because when we add more water or any other fluid, the weight will be more, so the pressure will be more. That's why pressure is directly proportional to height, and pressure is equal to unit weight multiplied by height. Okay, now this pressure at A, this is also called gauge pressure. Okay, P gauge at A. Why? Because we have not considered the atmospheric pressure too, right? Because pressure, if you see that, let me draw a line here. Oh, no need, let's do like this. See, here is air too, right? Around it is air. This surface is open to the atmosphere, so here will be P atmosphere. So pressure at B will be this pressure due to H, right? Rho GH plus P atmospheric. That is let me write this thing here. Pressure at B is equal to rho GH, right, plus P atmosphere plus P atmosphere. Because we have included this term P atmosphere in this pressure, therefore this pressure B is now known as absolute pressure. That's why we call it as P ABS for absolute at B is equal to rho GH plus P atmosphere. When we don't consider the atmospheric pressure, then the pressure is called gauge pressure. P gauge at B is what? Only rho G H. Okay, simple thing is when you add the atmospheric pressure, it becomes absolute, right? If you don't consider the atmospheric pressure, it's the gauge pressure. Okay, that's why if you want to consider this level A, now pressure at A is rho GH, of course, because due to the height of water, right? This is gauge pressure, P gauge, and there is also an atmospheric pressure acting at the free surface of this water, which is P atmosphere. That's why when you add gauge pressure and also include the atmospheric pressure, that's why it's called absolute pressure at A. Okay, now let's do some problem here. Let's say this height is 3 meters. Okay, and this is water. Okay, and you are asked to find what is the pressure, gauge pressure at A. Okay, and you are also asked to find the absolute pressure at A. Okay, now gauge pressure does not include atmospheric pressure, right? Oh, okay, so P gauge at A is equal to rho G H. Now density of water is what? Rho is the density of water. It is approximately 1000, right, kg per meter cube, right? Multiplied by G is 9.81 meter per second square. Now H is what? 3 meter, right? Multiplied by 3. Okay, this is 9810. This is meter, right? Multiplied by 3. Okay, so this is the answer. Okay, now if we'll use the calculator, let me use the calculator. 9810 multiplied by 3, it is 29430 Newton per meter square, right? Now what is the gauge pressure? Sorry, we found this is the pressure gauge at A, right? Now what is the absolute pressure? P absolute at A is pressure gauge at A plus P atmosphere, right? Because absolute pressure is rho GH plus P atmosphere. Rho GH we have already calculated. This is the rho GH, and we just have to add P atmospheric. So this would be 29430 plus P atmospheric. Okay, plus P atmospheric. Now if you will see this in Google, right, this atmospheric pressure is approximately equal to 101 kilonewton per meter square. This is approximation, right? So this would be 29430 plus 101. It is kilo, right? Kilo is 3 zeros, 1 2 3. Okay, when you will add up these things, you will get the absolute pressure at A. In this way we find the absolute pressures, I mean to say the static pressures. Okay, the thing is that the static pressure is directly proportional to the height of water or the height of fluid. above it. Okay, and remember, P gauge is unit weight of water multiplied by H, or unit weight of water is rho g, right, multiplied by H. If you are given with provided with the unit weight, you use this, and if you don't know the unit weight, you know the density, because we know unit weight is rho g, rho multiplied by g. Okay, then you can use this formula. Okay, and when you have to find the absolute pressure, okay, P absolute, it is simply gauge pressure at that point plus the atmospheric pressure. Okay, so that's it for today's class. We are going to solve more problems in the coming lecture. See you in the next class. Thank you. And yeah, yes, one more thing, the notes, okay, the PDF notes are in the description or in the comments. You will find the notes. You don't have to worry about the notes, and just be careful about understanding the concepts. Okay, the way I have explained it here, force divided by area, and how I did this thing, that's important. Don't worry about writing, because I will provide all the notes very clear in the description or in the comments. So see you in the next class. Thank you.